This is a short note on order parameters. Order parameters are used to describe the molecular orientation in liquids. So consider a liquid element. These might be different particles of the liquid. You can connect the end-to-end vectors of the last two elements by such a vector. Now if this liquid element rotates a little bit, then the direction of this vector of course changes. If you take any two unit vectors in a molecule, in a single molecule, and then you calculate the angle between them. So let's say the unit vectors are ui and uj, and if the angle between them is theta, then it can be shown that if the orientation is completely random, then the mean value of cos theta squared will be equal to 1 by 3. One can then define a second order parameter called P2, which is defined in this way: 3 cos square theta. Mean is taken over all elements and at all times minus 1. Now you can get the same order parameter from quadrupolar splitting in deuterium NMR spectra, and they can be directly used to calculate this order parameter. But since we know the positions of all particles, we can also do this in a molecular simulation. So if the orientation is completely random, then cos square theta is equal to 3. So P2 will be equal to 0 for random orientation. It will be equal to 1 if ui and uj are perfectly aligned to each other. Then the angle between them is 0. Cos theta is equal to 1. 3 minus 1 divided by 2 is 1. So if two vectors are perfectly aligned to each other, then this value is 1. Similarly, if they are at an angle of 90 degrees, cos theta is 0, and the value of P2 becomes minus half for perpendicular orientation. In the context of this course, we will use the definition of the order parameters to characterize the structure of lipid membranes. Now if you look at a lipid membrane, which looks something like this, the lipid tails are facing each other to exclude them from the aqueous phase. If you look at a carbon atom close to the head groups and compare it to the level of freedom with a carbon atom close to the end, you can clearly see that the conformational freedom of this carbon will be greater than the conformational freedom of this carbon. So as you go down along the lipid tail from this direction to this direction, you can plot something called the carbon deuterium order parameter. I will describe to you how this is measured in experiments. And this you can do versus carbon number as you go down the chain. So close to the head group region, this number is usually about, let's say, 0.2. And as you go towards the center of the bilayer, there is more and more conformational freedom. So SCD approaches 0 as shown here. Of course, there will be 16 or 18 points because each lipid typically has 16 or 18 carbon atoms. So this is what the order parameter profile looks for a typical lipid in a fluid membrane. Some of you may be aware that membranes also have phases. So a membrane can be in the gel phase where the lipids are more ordered, and in that case you can characterize this ordered phase by measuring the order parameter, which will now look a bit higher. This value may be about 0.4. In experiments, you can measure the same values by, for example, if you take this lipid, you can take this first carbon and replace the hydrogens by deuteriums, and in all subsequent carbons, you only have hydrogens groups, and this goes all the way to the last carbon, CH3. From this experiment, you can measure quadruple NMR splittings for this particular methylene group, and you can get one of these points. In the next experiment, you could replace these by hydrogen atoms. So this now becomes hydrogen, and these two become deuterium. And then you can measure the NMR splittings for this particular carbon. So you need to do several experiments to generate such a plot from NMR spectra, and this can be quantitatively compared to the order parameters that you measure from your experiments, because you know the orientation of each CH bond, and then you measure its angle with respect to the bilayer normal, and then you measure this particular value. So order parameters in the context of this course are essentially used to characterize the effects of drugs and proteins on the properties of the lipid membrane, as well as of the properties of a lipid membrane itself, whether it is in the fluid phase or what is called the